In this video, we are going to do revision exercise 8, geometry. You will find this on page 431 in the Namibia Ordinary Level Mathematics textbook, y equals mx plus c to success. Now, if I look at this example, it's all about angles. Now, it will be very, very good before the examination to just go back to the document and to just refresh your memory about all the different angles. And I'm going to start here, and I'm just going to quickly run through the tables, because that's what you must do before the examination. Okay, so a point, a line, parallel lines, perpendicular lines, intersection, congruent. What is congruent? It's if they are exactly the same. So the angles will be the same as well as the sides. I like to compare it with your hand. Can you see this hand? If you put your hands on top of each other, they are congruent. They are exactly the same. What is similar? It's if the shape is the same, but the size is not the same. But the angles, they will be exactly the same, but the sides will be in a specific ratio. So it's like I take this one and I times it with 2 to get 8 times 2 to get 4. And then I will come back to bearings when I do in the next chapter. Okay, I'm just going to take it up a little bit. But bearings is a direction given clockwise from north. So it's measured there from north clockwise. Okay, then the next. This is congruent. Maybe I'll come back to this. But for now, I just first want to just go to the angles. I will show you in this video also. And I will even search for an example if I don't have one in the exercise. I'm just going to angles. Okay, here is the angles. Now, make sure that you just know it's coming from grade 8 and 9. So if you see, this is an angle. A right angle is 90 degrees, a straight angle 180, a revolution 360, an acute angle is between 0 and 90. An obtuse angle, look at the obtuse, it's between 90 and 180, and a reflex angle is between 180 and 360. Okay, very important. Vertical opposite angles, if two lines intersect, they are equal. Adjacent angles is angles next to each other. And now let's just move up, and I just want to go through these rules very fast. Complementary angles, they add up to 90, and supplementary angles add up to 180. So you can just quickly go through the summaries, because this is coming from grade 9 and 8. Okay, and now I want to look at this one. Okay, angles formed within parallel lines. So if I look at this angle, this is the parallel lines, this is the Z, so that's alternate angles, they are equal. Remember it also for the example. Then the F, corresponding angles, the F, they are equal. And then co-interior, that's the letter C, they are supplementary, they add up to 180. So you just have to run through this basics. And you can remember it with the word fun. You can just make it a bit bigger. Okay, this is corresponding angles, this is co-interior angles, and this is alternate angles. Okay, and then I'm just moving on. Angles of a triangle. It's just very good that you just go through all the angles of a triangle add up to 180. And then the exterior, if you take one of the sides and you extend it, this exterior is equal to the opposite interior angles. So that will be equal. If I add up this to opposite interior, I will get that 152. And then if I go on, An isosceles triangle is almost like your legs. If your legs are the same, your feet will also be the same. But the base angles will be equal. And an equilateral triangle, all the angles are equal. So I basically just take 180 and I divide it by 3. And that's why I get 60 degrees. Okay, let's just see if there's few. I think I'm through the basics. A quadrilateral, maybe I can just show you. Also, I think this is coming from grade 9, so make sure that you know this list. Okay, so this is just having a quadrilateral. The one is a trapezium. It's having just one pair of sides that's parallel. If you look at this, this is two parallel sides, and the opposite sides are equal. The opposite angles, very important, they are equal. If it's they have a diagonal, they bisect, but they are not equal. So this is equal to this, and this is equal to this. And then if you look at this one, this is a rectangle. It's also having parallel, but now the diagonals, they will intersect and all four of them will be equal. And you can just look there. And then a rhombus, very important. It's almost like the parallelogram. The opposite angles, they are equal. And then this will be parallel, this will be parallel. And then this will be equal to this will be equal to this. So they intersect, but they are not all four of them equal. But very, very important, they intersect with 90 degrees. That's an outstanding property. And then the kite, the two adjacent sides are equal, and then basically just that diagonal will intersect, but not that one. And then basically, I think that's basically the property. Oh, they also intersect there with 90 degrees. And this one, this is a square. They also intersect there with 90 degrees. Okay, so it's very important that you just quickly run. It's best to just make your figure and start filling in all these signs to show these properties, because it can help you. It can even help you in coordinate geometry if you just know the basic properties. Okay, and I think I'm first going to leave. I will come back to polygons. So I'm first going to go back and I'm going to tackle that example. Okay. So in the diagram, PQ is parallel to SR. This is very important. You have to see all these things. So parallel, so you have to think of parallel lines. Okay. PQ is equal to QR. Okay, let's see. PQ is equal to QR. QR, oh, there I see that. So that, oh, and this is very important that you see this, because this is already, while I'm drawing it, I already can go and say, oh, I know you are just as big as you. Okay, that is very important. This is the base, this is the legs, this is the feet. Okay, angle is 63, there I have it. Angle, this is 100. Find the value. Now, before you even look at the question, you can just think of the properties of parallel lines. You can remember the letter Z, alternate angles, and you can fill it in. If this is 63, what will this one be? 63. You don't have to give reasons here. Okay. Then I said that this is isosceles. So this is also 63. So if I want to find y, I can basically just take my calculator, because all the angles of a triangle add up to 180. I subtract 63, I subtract 63, and so it's 180 minus 63 equals, and that will be 54. Okay, and then I can look, oh, I see here. Do you see that this is also parallel to this? Can I just indicate it here to you? You can just look at that signs also. Okay, so if I look at this sign, I can already, do you see my Z there? So if this is 63, okay, just let's look, Z, then this will also be 63. Okay, and then, oh, then I must just find that one. And I know this is 1, 2, 3, 4. It's a quadrilateral. So the angles will add up to 360. So I say 360 minus that 63 minus the 100 minus 63 equals, and I get 134. And did you see what happened? I was just filling it in. Now, I usually like to say this. You always do it like this. Start in a figure and try to fill as many as possible and then flow over to the next figure. Because now it's very easy and I'm just writing my answers down. So just know that properties. So the value of x is 63 degrees. B, the value of y, let's just find y, where is y? Value of y is, let's just 54 degrees. And the value of C, okay, no, it's Z. And what did I find Z? It's 134. You don't even have to show the calculations, but you can by writing it in. So I was just showing you the explanation there. Now, if I read the next question, the shape of a flower bed is a rectangular octagon. Are you seeing that? With sides 4 meters. Show that the interior. Now, this is a polygon. I want to first take you back to polygons, and let's see. You can go to the index, but it's page 370. That's what I see here. I made a note. I think this is too far. It's also nice to look at that in investigations. Just click on that QR, because sometimes it's also showing you where the angles is coming from. Okay, let me see, where am I now? 370. It's quite a lot still. Okay, let's see where I'm now. Oh, it's still 10 back. It's better to go out and then in again. Here it is. I just want to quickly go through this because this is not difficult. Okay, there I was, and then I was doing that, and then now it's coming. Okay, there's the properties of polygons. Now, just as I said to you, when you prepare for examination, you just go through all my summaries, go through all the blocks, which I showed you. Okay, let's just see. Just move it a little bit down. So there, where I summarize things, and then especially the examples that I do. So if I look at the polygon, it starts, the first closed figure will be 3 sides, 4, 5. It's triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. Know that names. Okay, now if I want to find the interior angles, you use this formula. Do you see there? N minus 2 times 180, where n is the amount of sides. And if I substitute, I'm just getting these values. But this is very, very important. The sum of the exterior angles, and how do I get that exterior angles? And I just want to show you quickly a figure and see if I find one. Okay. No, let's just go back. Okay, the exterior angles, and I think the best will be is if I just make my own figure quickly. Doesn't matter, I'm just going to at least, it's going to be irregular. Okay, and then if it's exterior, I just extend the side. And then I walk, and and I remember my ruler is not as good as yours, and I extend the side. And I extend the side. I extend the side, I extend all around, and then the exterior will be this plus this, the sum of the exterior plus this, and I will always get a sum of 360, and that helps me also to do calculations. Okay, so, and then very good, it will really be good if you just go through this basics. So if you say a nonagon, it's 9. With 9 sides, calculate if the interior angle, that's not the sum, so you first do the sum, you work there with n minus 2 times 180, and then you just divide it by 9. Okay, and then each angle of another regular polygon is 150. Calculate the number of sides of this polygon. Now, first get your exterior angle. It's like they gave you they gave you the interior angle, this one. I must work without the ruler. So they gave you this one, and this one is 150. So you're first going to extend that line. This is actually what I wanted to show you. You extend. It doesn't matter which one. It can be this one or this one. And then this is now a straight line. And a straight line is how many degrees? 180. So 180 minus, and it's 30. And now I use this exterior. This is exterior, and this was interior. And then I say, but the sum of total is 360. Divide by that exterior. And then I will just get its 12 sides. So this is always very, if they give you exterior, excellent. Just say 360 divide exterior. But if they give you the interior, first make a sketch, get the exterior, and then divide, and then you find your sides. And actually, that's what I wanted to show you. This is regular, but then with irregular, it's not so difficult. I just think you can also just look at a few extra ones. The sum will still be the same. It will just be different values. Okay, but you can again look at there are a few examples and there are a few examples. Okay, let's go back. Let's go back to the question. Okay. Number 2. The shape of a flower bed is a regular octagon with sides of 4 meters. Show that the interior angle of a regular octagon is 135. Okay, octagon, it's 8 sides. And the formula for the sum of the interior angles is just going to be n minus 2 times 180. Just know that. Okay, so because a triangle is 180, and then it will be 3 minus 2, and then so on. So now I will just say 8 minus 2 times 180. Okay, and if I do that, I'm just going to get that, that is going to be the sum now. So this will be 6 times 180. And that will be 1, but that's the sum. And they just want 1. So 1 interior angle of octagon, it's 1080 divided by 8. And that will be 1. And just remember, if they say show, that means you must arrive at that answer. You must not use it, you must just get it at the end. And if you're not getting at the end, you know that your method is incorrect. Okay, so that is polygons. Just quickly go through it. It's not difficult, but you have to refresh your memory on that. Okay, let's do the next one. Okay. Now, if you look at this one, triangle ABC is drawn accurately. Measure and write down the length of AC. Now, sometimes it's a bit more difficult. I hope it's going to work now, but I'm just going to use. So this is constructions, and you will find that if you just want to revise that. I'm not going to do it now because it's easy, but you can go, it's 415, page 415 to 422. Okay, so 415 to 422. Now the length of AC. Now I hope I have a ruler. I just want to see if I'm going to get it correct. Okay, and then basically, I don't think I must try my ruler on this one. It must, oh, there it turns. Okay, now according to me, if I look, yours must be 9 in your textbooks, and it must be, then you use, I'm just going to show you the method, then you use your compass, and I'm just showing you how to put it. So that was AC, mine is now not accurate because I was importing and exporting, no. But if you use, and you must find now angle CAB, I just want you to, how to use your instrument. So it seems to me mine is saying in my textbook, this was 9 centimeters. And then this one, it was angle CAB. Where is CAB? So it was not this one. I want to just take this away. And then I just want to show you how to move it. So it's CAB. So it's actually referring to this angle. Then just take your compass, and I'm going to show you just how to move it. This must be in the middle. Do you see there? My lines is again not good. And then I'm just going to, you can even put it like this. So you just have to put it on one side. Now, I cannot see very good, but you don't then start measuring on this one. You measure the one that starts with 0 because I'm starting on this side. And you measure it from there to there. So on this scale, you will read it down. Just want to see, you can also do it like this. Do you see? And then now you will measure on the outside scale. But if it was correct, my book is saying 54 degrees. You can just check there. Okay, I'm going to come back to this one. Now construct accurately the locus of all the points 7 centimeter from C. Now before I do that, I first want to show you this. Loci. This is really not very, and this is very important, very, very important if you want to be able to do Loci. There's only 4. And I'm going to explain it here, and then I will go back and I will just do it. So the 4 things will be 1 point, 2 points, 1 line, 2 intersecting lines. Now, how do they name a point in mathematics? They will say from, they will just use one alphabet letter, a A or a B or a C. That's 1 point. A line, they will say from, they will use 2 capital letters next to each other with nothing in between. And equidistance from 2 points, they will say from A and B. So they will also use, but they will put an and. So it's 1 point, 2 points. And then 2 lines will be like in this one, AB from AB and BC. And usually the letter that's repeating, that will be the intersection point. Okay, so this is very important. You must go and look for that to determine if it's at 1 point, 1 line, 2 points, and 2 lines. And now you must go and memorize this. From a point, it will always be a circle. There's the Loci. From a line, there is the line, it will be 2 parallel lines, 1 on top, 1 at the bottom. From 2 points, it will be the perpendicular bisector, where I will take the compass, put it there, make more than a half, and make your cross. Put it on the other side without stretching it, more than a half, cross. But go and look at the individual videos if you struggle. And then where they intersect, I draw that line, and that will be the perpendicular bisector. That's my Loci. And then equidistance from 2 lines, that will be the bisecting of an angle. So you take your compass and you put it there, and you cut, and put it to that side, cut. And then remove the nail, put the nail there, and then make in the middle, put the nail there, make in the middle, and then just draw your line. So very, very important. You first have to revise this before you start with an exercise. Okay, I'm going to go back. Okay, so construct accurately the locus of all the points from C. There you see. What is C? C is a point. So what is the loci going to be? That's going to be a circle. Okay, so from C, and I go back, and how many? 7. Now remember, mine will not be accurate. I'm just guiding you how to do it. So I'm taking my compass. It's from C. I even want to get rid of this one. Okay, there's my compass, and I go to C. And again, I just want to guide you. Okay, let's see, where's the nail? This is the nail. Okay. And now I need a ruler also. The why I'm needing a ruler is to make it 7. So you can again take your ruler. Okay, it seems to me it's almost 7. Okay, but you have to do your own. Now if it's not, I think mine will I can stretch it a little bit to make it a little bit longer. Doesn't seem to me want to be there longer. Oh, here I can stretch it a little bit. Do you see? Okay, and my nail is this, and it's blue. So basically, that is now approximately 7. And now I just want to turn it. So you put the nail, and it's best if you just work from the line. You cannot be inside because you just want to do the triangle. And then let's see if I can do, oh, excellent, excellent. Please don't leave a gap, they will penalize you. So they want that circle. Okay, that's the loci. Let's go back. The point X lies outside the triangle ABC with CX 7 centimeters and angle BCX. Okay, let's just see. BCX is 60. Draw accurately the line CX. Okay, so I have to construct again. Go back. So CX is outside, and they say angle, and can I just show you BCX? Just remember BCX. So with BC, it means it's here. Can you see? Okay, so I must now take my compass, and I'm going to, and again, yours will differ a bit from mine. I'm just going to put it nicely here. Okay, I just want to move this a bit. Okay, so I put it nice. I just want to know why it's so light. I don't like the light. Okay, now I already showed you constructions there. Let's just clean this. So, and they say it must be 7, 6, and I hope I will be able to see that. Okay, this is 0, so it will be, and I'm going to just make it very big that I can see it. 67. No, not bigger. Okay. Okay, I can also see now my triangle is not so good. I'm going to just move it a little bit back. Okay, and then I'm just going to 67. So it seems to me, okay, it seems to me there. So because it's just a little bit, and now the writing is also there. But make a mark, and then take your ruler, and I'm going to just use another color, and from there to there. Okay, so that angle will be 67. Okay, and now they also told me, now I just have to go back. You can check in your textbook. I'm just checking in my textbook. The angle is underlined CX. Now, where is CX? CX. That line is exactly 7. Okay, so I'm just going to make it smaller again. I have my angle, so let's get rid of this protector, and I take this, and I must just make it longer now. Okay. And it must be 7. Okay. Sorry. This must be 7. Now I just want to move this a little bit down again. I have to make it bigger, that I can see. Okay, then I can see. I can otherwise not see. Okay, I think it's better. Just get this. Let me get my green, and it must be 7. Okay, let's go. And it must be up to 7. Remember, I'm struggling a little bit with the technology. You can do it without technology, which is nice. Okay. Just with a ruler and a pencil, sharp pencil, please. Okay, my line is not so good, but please, please, please. What I can do is, I'm going to not make it. Don't do it like I did it now. It's better that you just take it from there to there and draw your line through that point that you measure there. And this one will then be X. And then I'm just going to construct this again, make this part of my line, and I'm just going to go to this. I go from X, I'm just going to go back, make it smaller. Okay, so basically I constructed it. Let's read again. Okay, that's what I did. 7 and the degree, draw accurately CX. Draw the line BX, that's what I was drawing. Measure and write down the length of this line, and I'm just going to give it to you. According to my accurate drawing, it was 9. It was 9.6 centimeters. Okay, and now using a stretch edge, you can only construct the low key equal. And what is that? What is that? That is 2 points. And can you still remember that summary? 2 points, that is bisecting the angle. You just have to memorize that 4 points. Bisecting the angle. So I go back. And I have to just check. What is the angle? BC and BX. So it will, which one is repeating? B. So it will be B. Okay. So basically, I'm just going to take my compass, and I'm going to try to do it again here. Okay, here it is. Okay, there it is. I can move it here. It's angle B, so I put it there, the nail on B, and I can just move it a little bit around. Okay, this is now, what is that angle that they said I'm going to read? It's this angle because it's BC, and it's going to be BX, so it's this angle. So I'm going to make it a bit shorter. And again, I have my construction lines. Leave it in. So just go up, and then I'm rotating it still, and make your line again there. And then I'm rotating it again. I'm rotating it. Do you see? Put the nail in there at that point, and then don't stretch in between. So put it there. And then I'm rotating again. And then, okay, no, not there, sorry. In the middle. So first go a little bit more to the middle, and then draw it there. And then move it. And move it around. And still move it a little bit around. And then rotating it there. And then I'm just going to draw. So I could have used a pencil, but still pencil. And then I'm just going to use my ruler. Where is my ruler? And the thing is, I must work very accurately. Sharp pencil, sharp pencil. And then I put it on that corner. And also, sorry, and as I said, I'm struggling a little bit more with my technology, but I'm actually impressed what I can do with this technology. It's really nice. So we put it there. Okay, and now I just use, and very, 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 very important, you cannot draw the line only up to there. You have to draw it, that the whole figure, that it intersects, oh, sorry, you have to take, I'm taking my ruler, but I'm not taking my real ruler, and you just do this with it. Okay, and then basically, you just keep, and that is what you're supposed to get. So please don't stop there. Continue until you cross that line. Sometimes they are shading, and can I just mention this to you? You can check in the textbook. In linear programming, we shade the unwanted, and in this Loki, we shade the wanted, and it's almost like sets. It's almost just like sets. I shade the two areas that overflow, that area I shade. So just like I did the shading in sets. So keep that in mind. That was Loki. Please go and practice still a little bit that Loki. It's also easy marks to get. And make sure you have a compass. Make sure you have a ruler. Borrow one if you don't have one. And a sharp pencil. And make sure that you score that marks. Okay. I'm going to do circles. Now before, and this circles, I like doing circles like this, and I'm going to show you now. First, I must go through the summary, and I must memorize that summary. And it's nicely here. I'm going to show you. And I'm going to show you, and I must memorize that top phrases. Okay. Now, this is very, very important that you memorize these properties. So, and I'm going to try my best to show it to you as best as possible. If you go from A, and I want to take red, and you go from A and you go from B, and you draw a line to the circumference. This is the circumference. And this here at O is the center. So if you draw a line to the circumference and from B to that same circumference, and then you draw a line to the center, I'm showing you this center, and you can even see it is twice as big as the circumference. So if this is 20, then this one will be 40. But be careful, sometimes you don't see this one. Again, from A and B, it goes to the center, but then it goes to the circumference, just on the opposite side. But then just be careful, because it's this angle that is twice as big as this one. So if this one is, say, for example, 300 degrees, then this one will be 150. You can even say, I go to the circumference and this, but be careful for this one. And you have to memorize, and I'm going to highlight, I never use highlight, but angle at this, now let me rather not put it so. Angle at the center is twice the angle at the circumference. Memorize that. Angle at center, twice as big as the angle at the circumference. Now, this one, the next one. If you have a diameter, do you see my diameter there? It's going through the center. And any triangle that you draw towards the circumference, so any angle angle that you draw towards the circumference, that will always be 90 degrees. That's a nice one, easy one. And we say an angle, I want to take again my highlight. An angle in a semicircle is a right angle. So this angle will be 90 degrees. Okay. And then I'm just going to say, okay, there. Angles in the same segment are equal. Can I just show you? If I go again, but this time I don't go to the center, I go to the circumference and again to the circumference. Okay, so 2 times to the, then they will be equal. That means if this one is, take red again, if this one is 30 degrees, then this one will also be 30 degrees. Okay, so angles in the same segment are equal. Very important. And I want to highlight it again. Angles in the same segment are equal. Memorize it. Okay, now I'm at the cyclic quadrilateral. Can I show you here? Now, a cyclic quadrilateral will be when all 4 points will be on the circumference. All 4 of them. It can be, so not one in the middle and 3 on the, all 4. And then it's cyclic quadrilateral means then that this opposite angles will add up to 180. They are supplementary. They add up to 180. Okay, so I can just say angle in opposite segments are supplementary. Opposite angles in a cyclic quadrilateral are supplementary. Okay, doesn't matter. And then the next one, this is also a nice one. If you have a tangent, I'm not done with that. If you have a tangent and you have a radius, okay, so it must be a tangent, it must just touch, and that radius, and that angle, okay, that angle is 90 degrees. I must take my ruler. That angle is 90 degrees. So the angle between a radius and a tangent will always be also a very nice one. They love to work with this one. Angle between a tangent and a radius is 90. This one you don't see so often, but it's always like, say, if 2 tangents are drawn from an exterior point. So there's the point outside. And then they draw 2 tangents. So this will be a tangent. And this will be a tangent. And then always this 2 will be equal. If this is 7, then this will be 7. And I can say if 2 tangents are drawn from an external point, then the length of the tangents are equal. The line joining the external point, the center, bisects the angle. So that line will just cut that angle exactly in half. Okay. Now, I always say that if you do this, I even sometimes make a small sketch. Now I will show you now, because I'm having so many. You can just want to count quickly with you how many are there. Okay. No, it's not. It's in the summary, and it's I think, yeah, it's in the summary. And usually I look at the previous page to just see the page number. So it's 434, 435, 436. The AS level I was marking it better. Okay, but I just want to show you quickly. So if I look at this, this was, can I just maybe, this is the first property, the second property, the third property, the fourth property, the fifth one, and the sixth one. So please learn them. And I even will make a sketch to just remind you of all 6 of them. So now I can tackle the examples. Okay. Now, as soon as I see a circle, I like to do it like this. I just quickly make a rough sketch of all the properties. And I think I'm going to start, and I'm going to try to do it exactly in the same order as do. So let's start. The first one. Let's make, I wish I had better circles now, but unfortunately you have to make peace with my circles. Okay, this is my first one going to be my second one, my third one, fourth one, fifth one, sixth one. Okay, so the first one, and I just say there's the center, and I just make a picture for myself. Okay, I'm probably going to use a little bit of a line here. I wish I could do better circles, but I'm not so good in that. Just reminding me, and to remind me, I'm basically saying I make one stripe, I make two stripes, it's twice as big. Okay, then the second one was, if this was the center, then I say this is the diameter. An angle in a semicircle. What is angle in a semicircle? That is going to be 90. Now, I want to make it red. Okay, you don't have to do it as accurate. I just want to reflect back to all of them. Can I just make all your centers? Okay, so this was the second one. And then the third one I memorized was angles in the same segment. So it's just that in this case, it's always coming from the same point. Get my ruler again. Don't waste unnecessary time on this. It's just for me to just help you to identify. So I'm just going to say this is equal. Okay, so angles in the same segment are equal. And then the next one, a cyclic quadrilateral. Now, how is a cyclic? Now, a cyclic quadrilateral will have how many points touching the circumference? 4. Okay, and then I know that this one and this one will add up to 180 degrees. Opposite angles add up to 180 degrees. Okay, so this is a cyclic quadrilateral. And then, oh, this is a nice one. This is my tangent. And this is my radius. I think I want to rather do it in yellow. And this is my radius. My line is not so good. I think there's a method to move it a little bit up. It's not. Can I see this one? No. Sorry. I don't get it correct. It's not. Okay, it's better. And that angle between a radius and a tangent will always be 90 degrees. That's my fifth one. And then my sixth one is if you have a point outside and you have two tangents. This is not good. Okay, let's do it again. Okay, I'm not good at this now. Okay, doesn't matter. For me, it's more important that you just notice this is equal. And if you draw a line, it will cut into half. So this must be in your memory. Because my method of doing it is I look at it. I look at all the information and usually they write it in. And then I start running through the 6. And before I even look what is the questions that they asked me, I just go and say, okay. The chords PR and circle intersects at T. Angle at this is 20. The angle, so just go through the basics. Find the angles. S here and T and this is this. Calculate the length of TQ. Oh, I'm so glad this is a similarity question. And I really have to show you similarity still. Okay, I'll do it now. So let's first, okay, it's my video, so I can decide how I do my video. So I'm going to skip 4 and first do B and C, A, and then I will come back to this one because I want to clean this and I need this now for this. Okay. So, because it's my video, I can decide. So, let's first do number B and C. And then I will come because I want to show you that similarity. Okay, so basically, I'm just looking, this is a cyclic quadrilateral because 1, 2, 3, 4, as long as there's 4 on the circumference, is the tangent of the circle at E. Okay, let's just see the tangent of the circle at E. G is parallel. Oh, this is very important. Bring in parallel lines. Fun, okay. Calculate angle G. This. Okay. I like first running through. There's not at the center. Is there? Oh, I see this. No, they didn't say. Oh, EF is a diameter. This is very, very important. This is a diameter. And if it's a diameter, I already see this one. Do you see? And I'm going to show it to you. Do you see that? So already go and mark that that one is how many degrees? 90 degrees. Okay. And now, okay, is it, let's see if I find one there. There's my points. It goes circumference, but it don't. This one goes there, but it don't. It's not there. Cyclic quadrilateral, it's there. I see it. So I know that this angle and this angle will add up to 180 degrees. Okay, they will add up to that 180 degrees. And then, do I see, oh, look here. I see my tangent, I see my radius. And if I see that, I know that that angle will be what? That angle will be 90 degrees, and that angle will also be 90 degrees. And just take note, that one there, up to there, it's a little bit lower, but up to there it was 150. And now I will just start filling it in. Okay, it's actually from there to there, so it's the 90 there. Okay, now I'm looking, I can just check if I see something. I actually just see that 115. So if I'm looking at that angle there, and let's just quickly see that one. I just want to see where is the 90. Okay, I see. Do you see now unfortunately, can I just make it just smaller? Because that I need that. Can I just show you here? I'm just going to show it a bit. So this part is 90, but up to there, it's 115. So if I want to find that little part, then I'm going to say, I'm at number B, I'm going to say 115 minus 90, and that is going to be 25. So I know that that one is 25. I know that that is 90. So then I can just say 180 minus 90 minus 25, or I can just say 90 minus 25, and if I do that, I will get 65. And then I know the blue, that is supplementary angles. So I can say 180 minus that 65, and 180 minus 65, and that's 115 degrees. That is that angle. Okay, and now I read the question. Calculate angle GEH. GEH. Okay. Oh, do you see? I'm on my way. This is parallel, and I want to show you this. Don't forget your normal geometry. Parallel lines. So if this is 25, then what will this one also be? This one will also be 25. So angle G, where am I now? GEH. So I have that one, I have that one. How will I find? Oh, I have that is 90, and that is 25. Remember, can I show you also? What color can I use? Blue. That this and this is also supplementary. Opposite angles are supplementary. So if I want to find GEH, this angle here, I can just take the 180, I subtract the opposite, and I subtract that part, that 25. And let me just see. If I press that on the calculator, 180 minus 65 minus 25 minus 25, and that will give me exactly GEH. Let's just see, because this is now not giving me the correct answer. I just want to control. So this will be 180. Oh, I see my mistake. I see my mistake. I don't know if you see it, I see it. This angle is not 65. I'm just going to show you. Sometimes I like making mistakes because maybe you make the same mistakes. This angle, this was 65. This one is 65. That one, the red one, I showed you the angle in a semi, that's 90. So it's 180, and then I'm going to correct here, minus that 90, because that opposite angles are supplementary. This one is quite challenging. Okay, so 180 minus 90 minus 25 minus that 25 will give me that blue. And if I do it now on my calculator, 180 minus 90 minus 25 minus 25, and that will exactly give me 40 degrees. So, and I like always ending nice. So therefore, angle GEH equals 40 degrees. And that's the final answer. That one was quite challenging. Okay, I want to do C, and then I come back to A. I think what I'm going to do is I will first even do 5. No, let's do, will work. My order will work. Keep this. I'm just leaving this because you have to memorize that. So I'm starting this. A, B, C, D are points on this circle. So let's just see if I have 1, 2, 3, 4. Oh, it's again. And what do we call psi? And let's just make sure it's going to be. Where do I write it? It's a cyclic quadrilateral. Okay, so this is mine. So again, I have a cyclic quadrilateral because look, there's 4 points on the circumference. So remember. Okay, then I gave you, this is 140. They gave you this one is 14. They say AD and DC. Take note, this is very important. AD, get my ruler. AD and DC. Okay, I calculate angle ACD. ACD. Look me at the end, they're asking this one. Okay, let's just get a pen. They're asking this one. Okay, let's start. I always first run through the circles, then I bring normal geometry in, like I know isosceles triangle, base angles are equal. I know all radii are equal, so it's almost to say, and if I want to show you here, all radius will be equal. So it means again I will have base angles that will be equal. Okay, so I can even run through normal, but let's go to the circles. Oh, look here. Oh, I love this. Angle to the center, angle to the circumference. So this one is twice as big as this one. So I already know that this one will be 70 degrees. Okay, then do I have a diameter? No, it's out. Do I have that one? So I didn't find that one, but usually you just do it like this. You put it there and see if it goes to the circumference twice. But it will usually have this shape. No. Oh, I have the cyclic quadrilateral. Please don't forget it. That means that that this angle plus this, okay, plus this angle will add up to 180, and this one plus this one will add up. Do I have radii? No. Okay, now I think of my normal. So if I have 140, then to find this, I will take 180, I subtract 140, and I will divide it by 2. So that will be 40 degrees, divide 2, and that will be 20 degrees. So I will get this is 20 degrees, and this is 20 degrees. Okay, let's see if I can find still something here that will help me to find that one, because I'm trying to beat this one. I have 20 here, I have 76. I know that these two are equal. Let's just see number C. Okay, 20, 70. So angle AOB is twice. I have that one is 70. Angles at the point is 360. Okay, so I'm just controlling 316 minus 14 minus 20, but I'm still looking for that one. It's quite challenging, this sums. I don't think you will get so difficult ones, but for AS level, I think it's excellent sums. Okay, so I'm just going to run quickly through the basics again. I have that this is 20. I have that angle ACB is 70. Then angles at the point, so angle AOB, that is going to be 220. So it seems to me I'm going to also need this angle. And I just say 360 minus 140, and that will be 220. I just write it better, 220. Okay. Angles at the quadrilateral will then be, okay, let's just see, where is my quadrilateral then? I want to see 1, 2, angles of quadrilateral OBC. Let me see. I'm struggling a little bit here. OBC. Oh, I found it. Okay, I found it. Okay, this was quite a lot of thinking. Wow. Okay, but I think I have it now. Okay, I must just show you now. Okay, this was challenging. Sometimes it's also good to see teachers also struggle a little bit. Do you see that that is a quadrilateral? Because look, it's 1, 2, 3, 4. And all the angles of a quadrilateral add up to 360. So if I want to find this little blue angle there, I'm just going to say 360 minus that 14 minus the 70 minus the 220. And if I press that on my calculator, 360 minus 14 minus 70 minus 220, I'm going to get on the dot, let's just see, 56. That means that this little angle, you were the problem. You were 56 degrees. Because as soon as I have you, I have that this angle, this total, and I'm going to make it green here. This angle is going to be this 56 plus that 20, so that green is going to be 76 degrees. And then I will get my opposite angles of a cyclic quadrilateral. And I will just say, because what is the question? ACD. Oh, they actually asked this one. So I'll first get this one. So angle ADC, then it will be 180, because this 2 is supplementary, 180 minus 76. And if I do that, I get the 180 minus the 76, I get 104. Okay? And now, if this is 104 degrees, I know the base angles are, so they are asking ACD. I know they are equal. So I can just say, I can just do it like this. Angle ACD is equal to 180, sum total of a triangle, minus that 104. And because the base angles are equal, I divide by 2. Wow! And I get that final answer. If I quickly do that, 180 minus the 104, and I divide by 2, and it's equal to 38 degrees. Wow, this was quite challenging. I don't think you will get such a complicated one. So know your basic rules. They're going to break it up in a B, a C, and a D, and that's going to show you the way how to come to that one. So they will ask you to work out that one so that you have the clue that you can work out this one, and then you can work out this one, and then at the end you come to that final one. Wow, interesting. Okay, I want to go back to A. I know it's a long video now, but I think I want to finish it in this video. So let's just go back to A, and I just need again a little bit of space, and then I'm just going to run quickly through similarity. with you, because I think that's also usually in an examination. Very important that you know that. Okay. Okay, so in this, find the values of x and y. Now, can we just run again? There's not a center, so this one is out. There's not a diameter, out. Oh, I'm so glad they asked this. Angles in the same segment are equal. So if that one is 21, this one will also be 21. Okay, and now vertical opposite angles are also equal, so that's 170. And now I can find y. This is a nice one. So all the angles of a triangle add up to 180, this triangle. So it's 180 minus the 21 minus the 170. And I'm just going to run quickly 180 minus 21 minus 117. And I'm getting my answer will be 42 degrees. Let's just see. Okay. That was easy. And let's just find the other one. And the value of x, this was now number 4a. Oh, I'm not writing good. And the value of x was equal to 21 degrees. Okay, that was easy. This is similarity, because this triangle is similar to this triangle. I actually think it's congruent. It's congruent. It's exactly the same. Okay, so what I will do, if it's congruent, then I will maybe make it, if I'm through up to chapter 12, I'll try to make another video, just a part 2 on this chapter, and show you similarity, which will actually be good. Otherwise, this chapter becomes too long. Okay, so let's quickly see. I can already fill it in, but I can see they are congruent because all their angles, the angles are the same, and it looks for me the same side. So SR, no, it doesn't seem to me they are exactly the same. The angles are the same, but they are in the same ratio. So okay, let's first look. SR, what is S? I'm just writing it in. 8.23. I will now see if they are the same. RT, where is RT, is 3.31. According to the information, I will see that. They are not congruent. How do I know that? Because otherwise this one would have been as long as this one. So they are similar. So I have to go quickly to similarity and quickly show you similarity. So let's just go. I'm going to be very brief on that. Go to the chapter similarity. And it was in the beginning. And I showed you a nice investigation there. I just want to quickly show you this one. Okay. I'm going to do everything in this example, just show you in this, and then I will just reflect to area and volume also, because there is not a question on that, but I'll just reflect quickly. Now, they are very nice in the exams or when they set up question papers. If they say in the diagram is similar, they will already go and they will name the angles in the correct order. So you just write it as they write it there. Because they say ABC is equal to DEF. What does that mean? A is as big as D. So, can I show you? This one is as big as this one. B is as big as E. B is as big as E. And then the last one, this one is as big. The last one is as big as this one. I could have made it blue. Doesn't matter. Okay, so similar figures, the angles will be exactly the same and the size in a specific ratio. But people, if you have this, students, then always go and write your ratios down. Now, I just tell people to do it like this. It's the first two over the first two. So it's AB over DE equals the last two over the last two, BC over EF. And it's the first and last over the first and last. Okay, and that will give you a constant value. So that value will be the same as that one, and we can call it K. And now you just fill it in. Okay, first they say angle B, so it's exactly the same as E, so it will be 113. And now you just fill in what you have. You have AB. I like to do it like this. I say I have AB. Okay, that's 4. And I have DE. What is DE? DE is 6, and I have EF, what is that? 5, and then they ask me BC. So usually I have 6, but 1 will be out of the game. You are out of the game. So I will work only with this. So I will just go and substitute and say 4 over 6 equals BC over 5. And algebra now, I cross multiply. So I say 6BC equals 4 times 5. I divide by 6, and I get that BC is 3 1/3. And that's how you find a length. Just write that. I'll show you now in the next. Can I just take it a little bit further, and I want you to revise it on your own. As soon as you come to area, you will do exactly the same. You find your 6 ratios or your 3 pairs, but now you will just say, the area of the small or the area of a big, and now you will take one of that ratios and you will just square it. So that if you, and I'm just going to, I hope, this one was now, I was wishing for a better one. Okay. Yes, I'm just going to show you very briefly this one. I think this is for me a better one. They like to make figures. So they like to say 2 areas of a hexagon is 25 and 6, but they use areas. So find the ratio of the sides of the hexagon. But this was just the sides. But I just want to see the following, and this was also not, I think this one was good. And I'm not going to do it. I'm just going to show you. As soon as you see its area, then you just take the ratio. So make it small. There will always be a small and a big. And then you take its 80 over 120. And it's always good if you simplify this. So it's 8, so it's going to be 2 over 3. Am I correct? 4 can go in 2 and 4 can go in 3. 2 over 3. And then, if it's area, you will just always square it. And now you will just say area small over area big, and that will be equal to 2 over 3 square. And then you will say the area of the small, you will fill it in, or in this case it's 0.25. You say the area of the big will be your x, or area big, and then you say 2 times 2 is 4, and 3 times 3, that is going to be 9. Okay, I'm just checking that. And then you just cross multiply. Okay, so remember, for area, you just take that one of that ratio, pairs, and you square it. And the last thing I want to show you is volume. When you come to volume, what do you do now? Volume is to the power of 3. So now, and this is all I'm showing you, and you can really go through these blocks. You see the pages running here, 3, 5, 7. Oh, I hate it when it's doing that lines. I cannot do something now. But now you will just take that and now you will cube it. And then you just say the volume of the big over the volume of the small, and then you still cross multiply. So for area, okay, let's rather say, when you just want to find a length, you just take K. If you want to find the area, you just take that ratio and you square. And if you want to find the volume, you just take it and you cube. But please run through the blocks and make sure it's really not that difficult. I just want to end off this video now. And I want to quickly do that sum for you. So I can clean this, and my whole reason was that I wanted to clean this before I come back, that I just have space again. And now I'm having this. Now, can I write it down for you? Now, in this case, I must just name the correct angle. So if I say this is 4, and this is A, and this is the second one. So if I say triangle, and now I SRT, SRT. Now I must think, which one is as big as S? It's P, so I must first write P. Then, which one is as big as R? Q. And then, which one is as big? T. T is similar. There it is. And now I write my ratios down. First two. So SR over PQ is equal to last two over last two. RT over QT. First and last, ST over PT. And now you just check. You're just going to work with 4. What do I have? SR. I see SR, and that's 8.23. Now, what do I have also? I have RT. I have that, and that's 3.31. What do I have also? PQ, and it's 9.43. And what am I looking for? TQ. Oh, this one. So sorry, you are out of the game. Okay, and then it's going to be 8.23 over 9.43 equals 3.31, and it's QT. And I cross multiply, so I get 8.23 QT is equal to 9.43 times 3.31. I divide by 8.23 and I divide by 8.23. And I press on my calculator. 9.43 multiply 3.31 equals divide 8.23. And my calculator is saying I'm QT. Therefore, QT is 3.79. And if everything was in centimeters, then this will also be in centimeters. Correct to 3 significant. Remember, that's for length. If you get area, just take that ratio, one of that ratio pairs, and just square it. And if you have volume, just take one of that ratio pairs and just cube it. Okay, the final. I'm so glad this video is now almost done. Okay, otherwise it became too long for myself. Okay, for the diagram, right, oh, this is coming from grade 9. Please, I'm not going to even do it now with you. I'm just going to tell you, if you want to quickly revise it in the textbook, just go to page 397. You get 2 types of symmetry. That is rotational symmetry, and you get line symmetry. So rotational symmetry, and can I just say, so for the diagram, write down the order of rotation. It's almost like if you put tracing paper and you just copy this, and then you make an arrow north, and you turn it around, and you see how many times the copied one fit onto the original one, and that will be 2 times on top, and when the arrow is at the bottom. So 5A will just be rotational symmetry order 2. And then number B, the numbers of lines of symmetry. Now let's just see if I take my pen and I just see, I think if I draw there and if I draw there, no, that was not nice. But it will only be 2. And then I'm just ending by say 2, let's just get it, 2 lines of symmetry. And that will be my final answer. Please, this is not difficult. Just please go through your properties in this chapter. Make sure you know all the different kind of angles. From a point, parallel lines, triangles, quadrilaterals, circles, and just know your basics. And this is going to be score marks.